Okay, 2.1, Law of Sines, the ambiguous case. So there were two cases that deal with the law of sines, and this is the second one. That's when we have two sides and then an angle opposite one of those sides. So that means that if I have A and angle A, these are opposite, and then B would be the next side. So this fits the criteria for that. So let's draw this triangle and see where we are. So A is 18, angle A is 25. So I'm going to start with a pretty long base because I have no idea how much the base is. So there's the base. We'll make A 25 degrees. So that's acute, right? So we'll make it this long. Mark what we have so far, which is that A was 25 degrees. And then A is 18, so A is across here is 18, and let's put B over here then somewhere, and then we'll say that this is side B, so side B is 30. And from here to here is 30, 18 is a little bit more than half of that, so yeah, that seems to work pretty well in there. So we'll put another line from here to here, and we'll say that's 18. Alright, that looks believable. So there's A, that's 18. I have a little bit too much over here, so I'm going to erase that so that I have a picture that sort of makes sense. And fill in that this is B. So I still have a side or an angle here that's missing and a side that's missing. But I have a pairing. I have A on side A and angle A, so I could write A over the sine of A, and that should allow me to find angle B. And once I have angle B, then I can subtract and find angle C. So here is the first pairing sort of that I want to make. Okay, so we'll do it over here. So it's 18 over the sine of 25 is equal to 30 over the sine of B. And that means that you cross multiply here, so 18 times the sine of B is 30 times the sine of 25, and divide by 18. So that means that the sine of B is 30 sine 25 degrees. It's an equal sign. Divided by 18, which is, I'm going to round this a little bit initially just to take a look at it, 0.7044. Okay. So that's what the sine of B is. So keep in mind that then you would have to take the inverse sine to find the actual angle. So that's the ratio of two sides based on the angle. So that means that the angle B will be the inverse sine of, and this is the reason that I wanted to write it down for this, and that should be 44.8. Okay, so far nothing is out of the ordinary, right? So this looks great. I can now continue, and if I know B is 44.8, then I can find the last angle, C, and I could say, well, C must be then 180 minus whatever 25 plus 44.8 is, right? So 25 and 44.8, that's 69, so it's 70. So C is 110.2 degrees. And then based on that being 110.2, then I can finish this problem and I could find out that side C, so I'm going to use the first pairing, right? I'm going to use the pairing that I had over here, A over A, so I can do 18 divided by the sine of 25 is equal to side C divided by the sine of 110.2 degrees. So let's see, if you cross multiply here, and then you should divide still by this. So it will be 18 times the sine of 110.2 degrees divided by the sine of 25 degrees. And that should give you that side C is going to be, I think it rounds pretty close to 40. Okay. So how in the world is this called an ambiguous case? Well, let's go back to the original triangle that I drew. So if we're saying that this is C, or that's side A and that's 18, how do we know that it wasn't 18 this way? right? Trying to make it so that looks to be about right. How do we know it wasn't 18 this way? Well, we don't, and this is why this is called the ambiguous case. This side can swivel, or it can rotate, and we do know the following then. If these both are 18, then that means that this angle here must be that angle. So here's your second triangle. Okay, your second triangle, and I will draw it out over here so that we actually see the whole darn thing a little bit better. So in this case, I'd have to make it look more like this. It was possible, or it would have been possible to draw this right away. I still have A at 25, I still have B at 30, and I still have A here at 18. But how do you find this angle now? Because if you put this in, and you do, and this is sort of why I left this over here by itself, if I now go back and do A over sine A is B over sine B, because now B is over here, I'm going to get the same angle. I'm still going to get 44.8. So you have to keep in mind, what you have to do here is you have to figure out on your own that you do have an ambiguous case, and that the angle that you get over here, that's what the inverse sine gives you. But this angle could have been in two spots, right? Yeah, if we think about our inverse sines and all that. So this was only the angle that they gave us. It could have been 44.8, which, if you think of this in the unit circle, so 44.8 would have been over here, but the sine over here would be exactly the same. And so how do you find that other angle? Well, keep in mind that was 180 degrees. So if we go this way, if we go back 44.8, then that's the second angle B that we should look at. So B could have been 180 minus 44.8. And this is why, again, it's called the ambiguous case, because there is a second angle that is possible for B, and that would be 135.2. Okay. The other way that you can reason this way is because you do know from that this is a straight line, right? And if that's the 44.8, then this angle is also 44.8. Then how do you find the angle over here? So keep in mind that B, that's little c, so that's new B, and that's little c. So new B would be the 180 minus the 44.8. Well, that means that if B changed, then C also changed. So this is now B, right? B is 135. Notice that C, while here C was an obtuse angle, it was a rather large angle, 110 degrees. Look at C now. C is much smaller, right? It actually became an acute angle. So C would be 180 minus the 135.2 that we came up with in the 25 that we already have. So that's 150, that's 160-ish, so that's 19.8 degrees. So there's our new C. Let's see, well, if C is different, then little c would have changed as well, wouldn't it? Okay, so now I am still going to use A over sine A, because that is what was given to me. So I'm going to say 18 divided by the sine of 25 is equal to little c divided by the sine of 19.8. Okay, and hopefully you sort of can feel that, C was a rather large side because it was a large angle. This case C should be much, much smaller, right? So side C is going to be 18 times the sine of 19.8, and we're going to divide that by the sine of 25, and when you do that, then C could have been 14.4. So C could be 14.4 as well. So I need to fill that in as well, right? 19.8. So there are two triangles possible, and that's why it's the ambiguous case. Okay, let's see, two sides and an opposite angle. So what do we have here? Given A is 5, A is 30, and B is 12. Okay, let's draw a picture. So we'll do one more of these. So A is 30, 30 is about here, right? We know B is 12. So let's make this 12. That's 30. That's B. And A is 5, and that would be about half of this. And again, I'm going to do this in a different color. And see, that would be about half, right? Okay, so is it possible? Okay. Again, just like last time, draw a sketch. Okay. There is a way to determine how many solutions a triangle has in this ambiguous case. So for a triangle, suppose that we know A and B, so the two sides, and that we know angle A. So this angle here is fixed. So if you can see that this angle is the same for all these three cases. Okay. How do you know how many solutions you have? Well, the last one that I just did is when A is smaller than B, or is smaller than the height. Sorry, if it's smaller than not the imaginary height, but the height that you don't know, but if A can swivel here and never really touch, then you don't have any solutions. Okay? If A is exactly the height, then we would have one solution. Now, I know we don't know the height, but yeah, we can find the height if we really wanted to. Sometimes you can get two solutions. So if A can swivel, right, and then it can touch the base here and there, then you can get two solutions. So this is the ambiguous case. So A is larger than H, but A is less than B. So if you extend this over here, notice that from here to here is B, but from here to here, this is what A is. So A can rotate through B or side B. Now if A is longer than B, then once it rotates, it would rotate not through B, but it would rotate beyond B over on this side. So then there's only one solution. Okay. We also have the case where we have an obtuse triangle, and in this case, if A is given and B and A are still given, so if A isn't large enough to swivel, then you won't get any solution. So we've seen this before. So A would have to be significantly longer than B, so that when you swivel it, so imagine again that you're swiveling it with this point sort of here, that you actually get to form a triangle. Okay? So that's sort of where you need to be, or the way that you can picture this. And I believe that's it. Thank you.